Hello everyone, this is Priyanshu Choubey. Today we will talk about soil mineralogy and chemistry. Minerals, what is a minerals and definitions, types and identification of forensic applications of minerals. So let's see what is a minerals. Introduction, the topmost position of the topmost portion of the Earth's surface is soil. Four-letter word soil has also been described as the soul of infinity life. Soil has been formed from rocks over a long period of time. First rock disintegrated into smaller pieces, physical weathering, and then underwent further a transformation to produce a smaller particles and or constitute minerals through various chemical reactions, chemical weathering. Soil is a unique product of nature which sustain life on earth, providing food, shelter and clothing to the its any beds. On volume basis, soil contains 15 to 35 and 15 to 35 of solid water, air respectively. Inorganic sand and silt, clay, and organic soil, organic matter. Phase constitute the soil solid portion in mineral soil where from a 95 to more than 90% and less than a 1% to 5% respectively. While sand and silt friction provided mechanical support for various activity, clay and humic substance are the seeds which control all the chemical reactions in the soil. Soil chemistry essentially deals with the chemical composition of the soil and reactions process and equilibria directed by the unique arrangement and orientation arising out of a variation includes by the soil colloids. In this slide deals with the fundamental of soil mineralogy and chemistry and their application in understanding the process and reactions operating in the soil. So let's see. We will start from rocks and minerals definitions and classifications. So rocks, the Earth's outer solid layer, lithosphere, is made up rocks. Rocks are naturally occurring uh, bound solid aggregates of minerals and mineraloids. Rocks found in the earth crust have been classified further as igneous, sedimentary, metamorphic rocks. Igneous rock derived from a Latin word igni means fire. Ignis means fire are formed through the cooling and solidification of magma or lava which have not undergone any appreciable change ever since their formation based on the texture. These are subclassified as porous textured that granite, diorite, gabbro, or hornby landitite, intermediate textures that rhyolite, andesites, basalt, fine textured filzite, obsidian, and some portion of basalt and basalt glass. Sedimentary rocks are once formed from a materials deposited from a suspension or precipitated from solutions or a re-cementation. They are usually more or less consolidated. This includes sandstone, uh, salts, limestone, and Metamorphic rocks are the rocks which have been greatly altered from its previous condition through the combined action of heat and pressure. For example, metamorphic rocks, marble, slate were obtained from the formation of limestone sedimentary rocks, granite, igneous rocks, and shell sedimentary rocks, respectively. Minerals. Minerals is defined as a naturally occurring inorganic substance, mostly crystalline, substance which has a sufficiently a specific composition allow is expressions by a chemical formula and physical properties that are a constant enough to be used in its different definitions and identifications. Mineral are further subdivided into a primary and secondary minerals. Primary minerals, these are the minerals which did not undergo much alteration chemically since deposition and crystallization from molten magma, molten lava. These have been formed at elevated temperature in absence of water and inherited from igneous and metamorphic rocks. Light colored minerals. Primary minerals are light colored minerals like quartz, feldspar, moscovita, or constitutes of igneous rocks such as granite, diorite, rhyolite, andesites, phalliциtes, and obsidiana. Dark colored minerals. Dark-colored minerals such as horn-blended ignite, biotite, etc., or constitutes of igneous rocks such as gabbro, basalt, and basalt glass. Quartz is a constitute of a metamorphic. Quartz is a constitute of a metamorphic rock. Secondary minerals. These minerals have been formed at low temperature and in the presence of water under hydrothermal condition from a weathering of a primary minerals such as calcite, dolomite, gypsum, apatite, limonite, hematite, gibbsite, and aluminosilicates. Clay minerals like vermiculites, cementites, and kaolinite, etc. Based on the size, frictions, and inorganic components of the soil are of three types: sand, silt, clay. Usually, primary minerals are present in a sand and silt friction, whereas the secondary minerals are predominantly present in a clay frictions. Element composition of the Earth's crust and soil. The dominant element present in Earth crust, the soil, mainly belongs lithophile elements, readily I, which readily ionize to form a stable ions. Top 10 elements are Earth crust includes oxygen 46 to 5%, silicon 27.6%, aluminum 8.1, iron 5.1, calcium 3.6, sodium 2.8, potassium 2.6, and magnesium 2.1, and titanium 0.16, and phosphorus 0.12. Content of none of the remaining 70 elements found in the earth crust individually exceeds 0.1%. Among these elements, oxygen is one such element which covers 90% by a volume of the earth crust. Thus, the minerals are a network of oxygen ions in which metal ions, cation, are spread. Chemical composition of the soil depends on the nature of the dominant primary and secondary minerals present in it. Before going to the chemical composition and mineralogical structure of these minerals, let us discuss some basic principle and crystallography, because most of these minerals are either crystalline and crystalline or crapitocrystalline. Fundamentals of crystallography. Crystal and crystallography. Fundamental of crystallography and crystallography. The crystal, a homogeneous solid formed by a repeating three-dimensional pattern of atoms, ions, or molecule, or bonded by a plane surface, symmetrically arranged with characteristics angle between them. I repeat again, a crystal is a homogeneous solid formed by a repeating three-dimensional pattern of atoms, ions, or molecules, or bonded by a plane surface symmetrically arranged with a characteristics angle between them. Crystallography is the study of crystal. The study of crystal has a two aspect, namely the examination of the external form and the study of the crystal has a two aspect, namely a examination of the external form and the elucidation of the internal structure. The latter is more important from the chemical point of view, but knowledge of crystal from the essential for fully understanding the internal arrangement of the atoms. Habit of crystal. The external shape of a crystal is called habit. The external shape of crystal is called a habit. It depends on the relative developments of the different phase. For example, sodium chloride separates as a cube from a neutral medium, but it turns out as a octahedral if a smaller amount of urea is present in a solution. The and if gum arabic is present, then it assumes a tree-like growth. Interfacial angle, despite the fact the shape of crystal compound may differ due to a development condition. Interfacial angle as always the same. Measurement of this interfacial angle by as an instrument called goniometer is a part of crystallography. A part of crystallography. So crystal symmetry. This is properly. This is a properly of the crystal of showing a similar appearance at both side of say a point, line or plane, or effect. It is rotate to a certain angle about axis. This symmetry of the crystal on external appearance is the result of a regular internal arrangement of its constituents. Four elements, namely center, plane, axis, and composite. Symmetry are used in describing a crystal. Center of symmetry, if a similar point lie on both sides equidistanced from a central point in a geometrical figure, that central point is called the center of symmetry. Center of symmetry, I repeat again, if similar point lie on both side uh, equidistant from a center point is in a geometric figure, that central point is called a center of the symmetry. Like plane of symmetry, a geometric figure in is said to have a plane of symmetry when for each edges. solid angle or face on one side. There is a corresponding edges, solid angle or face on the other side of this plane. Is other words, one side is the mirror image of the other side. This is also called a reflection plane. Axis of symmetry, when during the course of rotation about an axis, geometric figure repeats itself is appearance two or more times in one complete rotation. This axis is called axis of symmetry. If it is repeated four times in a rotation of a 130 of a 360 degree, it is said to have an axis of a four-fold symmetry. Other possible axis of symmetry is a crystal or a twofold, threefold of and a sixfold, corresponding to a two times, three times, and six times of repeated appearance in a rotation of 160. Mathematical analysis that five-fold axis symmetry is not possible. Composite symmetry, when show the combined operation of rotation about an axis and inversion about the central point. A geometric figure repeats itself in appearance. It is said to have an axis of rotary inversion if the figure is rotated 180 degree, and then inverted of axis is a two-folded axis of rotary inversion. Other possible axis of rotary inversion are three-folded or four-folded and six. Crystallography axis. Crystallographic axis, the geometrical forms of a crystal, is best described in terms of the crystallographic axis. These are generally three or sometimes four lines meeting at a point, which are cohesion so as to bear a defined relationship to a characteristic feature of the crystal, usually with symmetrical elements or principal face of a crystal, face on crystal, and refer to this axis which pass through a common point at the central of the crystal. I repeat again, crystallographic axis. The geometrical form of crystal is best described in terms of its crystallographic axis. These are generally three or sometimes four lines meeting at a point, which are chosen so as to bear a defined relationship to the characteristics features of uh, the crystal, usually with a symmetrical elements or principal face of the crystal face on a crystals are referred to this axis which pass through a common point. The center of the crystal. Standard or unit plane and parameters of crystal. Phase or planes of crystal are described in terms of the standard or unit plane. It is chosen in such a way that is should cut all three crystallographic axes. The intercepts being A, B, and C on X and Y and Z axis. I repeat again, it is chosen in a such way that it should cut all three crystallographic axes at intercepts being A, B, and C be on a Y and X, Y, and Z axis respectively. These are called as the parameters of the crystal. These are dimension of the unit cell. The direction and position of the axes are also fixed by a convention. The angle between them are represented by a alpha, beta, and gamma, respectively, where alpha is the angle between y and z axis, and beta is the angle between a y, x, and z axis, and gamma is the angle between x and y axis. Crystallographic axis like OX, OY, OZ parameters. OA, OB, OC is a unit cell. Space lactic, the internal structure of crystal, the regularity of crystal growth, and the fact that a large crystal could be broken up by cleavage into a number of small crystals having a shape of original crystal led to the development of idea that crystal is a build up of a number of very small units. The regularity of crystal growth and the effect that a large crystal could be broken up by cleavage into number of small crystal having a shape of original crystal led to the development of the idea that a crystal is a buildup of number of small units, each having a shape related to that of a crystal as a whole. This has given rise to the development of the concept of shape lattice, which is based on the regularity of the internal structure of substance in a crystalline state. A crystalline matter is composed of a points arranged in defined shape pattern. Each point can be considered to be the center of gravity. Atoms, ion, partially molecules, or molecules. The regular arrangement of points in space is called a space lattice. Each point is in the lattice has the same environment as any similar points. Each space lattice is an assemble of a units of elementary cell. A cell consists of the smallest number of units, which completely determine and the shape lattice. Brothers lattice. Brothers lattice, a mathematically study of arrangements of points in space, indicates that three are only 14 different arrangements in which there is uh, exactly that same arrangement of points about any points um, as about any other one. Following the earlier work by ML Frank, Franklin Auguste Braves in 1848 demonstrated in existence of this 14 lattice. Today, they are usually referred to as the Davis lattice. Miller indicates in the method each phase is described by the three in categories in categories HKI, which give the ratio of the intercept of the unit planes to those of given phase. Thus, if the Miller index is 120 is a 212, then A upon P is equal to P upon Q is equal 1, and C upon R is equal to, where P, Q are the inter- intercepts of the concentrate phase, and B, C intercepts of the unit of planes x, y, z axis respectively. If a plane does not make any separates is data parallel to any axis, that then that intercept is taken as infinity, that the ratio or the index becomes zero. For example, a plane parallel to x and y intercepts z axis x at a 1c, then the ratio AP is equal A, and upon infinity is 0. The ratio B upon Q is equal B upon infinity 0, and CQ is equal C upon 1, C upon 1. Thus, the index will be 0, 0, 1. So here completed a basic information about mineral structure, minerals, elements composition of the earth and soil, and fundamental crystallography about crystal and crystallography, habit of crystal, interfacial angles, what is a crystal symmetry, crystal symmetry. We saw four elements, namely a center plane, axis, and composite symmetry. After that, a crystallographic axis, standard or unit planes and parameters of crystal. Space lattice, the internal structure of crystal, and we talked about Brevis uh, lattice and Miller indicates. So here for some basic information about minerals almost completed. Next slide we will talk about point group crystal classes and crystal systematic systems, and structure, properties, and weathering of solids, classification of solids, and covalence or network solids, ionic solids, molecular solids, melamelic solids, metamelic solids. So here almost done. Thank you.